Welcome to your custom deep dive. Today, imagine a bizarre, waxy, slate gray mushroom.
Right. It looks a bit like it's melting, honestly.
Yeah, exactly. And it serves as this high-rise bug hotel. But I'm not making this up. It contains actual, literal rocket fuel. So using the recent mycological research you provided, we are exploring the Helvella lacunosa, commonly known as the Elfin Saddle. So, okay, let's unpack this.
Yeah, let's do it. Because, I mean, its physical architecture is just as wild as its chemistry. It features this folded gray cap that actively acts as a hydraulic system.
Wait, hydraulic, like to shoot spores into the air?
Exactly. It relies on turgor pressure. So the fungus actively pumps water into these microscopic spore-bearing sacs called a hive.
Oh, like tiny cellular water balloons?
Yep, and as the water pressure builds up inside them, they eventually just burst.
Yeah.
And that launches the spores outward at, like, incredible speeds.
So it's basically a microscopic water cannon. That is wild. And, the stem holding up this water cannon is just as fascinating.
All right, the stipe.
Yeah, it's deeply fluted, full of these hollow chambers and crevices. It actually reminds me of the flying buttresses on a Gothic cathedral. Like, mostly empty space, hollowed out, but structurally unyielding.
That's a great comparison. That chambered stipe is just a brilliant piece of biomechanical engineering. Because the elfin saddle fruits in late autumn or winter, right? So it needs intense mechanical strength against heavy rain and snow.
Which the fluted design gives it.
Exactly. It achieves maximum structural support while using the absolute minimum amount of fungal biomass. And those deep, sheltered crevices end up serving an unintended ecological purpose, too.
Right, the millipede mansion.
Yeah, they become a safe harbor for insects,
Yeah.
protecting them from environmental extremes.
But okay, that cathedral-like structure isn't just sheltering bugs from the weather, it is holding a highly volatile chemical payload. And here's where it gets really interesting.
It really does. So the fungus produces a mycotoxin called gyromitrin. When someone eats it, the acidic environment of the human stomach triggers a hydrolysis reaction, and that converts the gyromitrin into a compound called monomethylhydrazine, or MMH for short.
Which is the rocket fuel.
Yes. What's fascinating here is that MMH is incredibly reactive. That is the exact reason it's used as a liquid propellant in the orbital maneuvering engines of the space shuttle.
That is just insane to me. But inside the human body, I imagine it's an absolute disaster.
Oh, totally. MMH actively depletes vitamin B6, which your brain desperately needs to synthesize GABA.
And GABA is like your central nervous system's primary inhibitory neurotransmitter, right?
Right. So without it, your brain essentially loses its brakes. That leads to, severe neurological issues, delirium, and refractory seizures.
Honestly, I struggle to believe people are actually out there foraging for this. I mean, if traditional preparation involves boiling the mushroom to neutralize the toxin, and this chemical is highly reactive, wouldn't boiling it just release a literal propellant gas right into your kitchen?
That is exactly what happens.
Wait, seriously, so you're not neutralizing it, you're just aerosolizing it?
Yeah, and that is the exact mechanism behind what's known as roommate poisoning.
Poisoning.
Yeah. To make the mushroom even remotely edible, it requires intense parboiling. But since MMH has a relatively low boiling point, like around 87.5 degrees Celsius, the toxin vaporizes rapidly as the water heats up.
Meaning if you are just sitting in your kitchen, say, reading a book at the table, while your roommate parboils these mushrooms in a poorly ventilated space.
You are inhaling raw rocket fuel vapor.
Wow.
And people get violently ill from exactly that scenario.
Yeah.
And to complicate the risk even further, recent DNA sequencing has basically shattered the cosmopolitan myth of this fungus.
Oh, right. We used to think the elfin saddle was just a single globally distributed species, didn't we?
We did. But the new research reveals it is actually a cryptic species complex. It's made up of 49 or more distinct genetic lineages.
So depending on which tree you're standing under, you might be dealing with a completely different mushroom.
Precisely. The danger varies wildly. Like Helvella vespertina grows under pine trees, while Helvella dryophila favors oaks.
So foragers or scientists trying to study this fungus are dealing with radically different concentrations of gyromitrin depending on the specific lineage and the local environment.
Yeah, you just simply can't rely on historical safety guides anymore. It's too unpredictable.
It just goes to show that the natural world, even a little gray mushroom growing in a nearby park, is hiding complex evolutionary warfare right under our noses.
And we are only scratching the surface of that chemistry, really. The sources also highlight this bizarre paradox.
Oh yeah, the polysaccharides.
Right. While this mushroom produces lethal hydrazines, it simultaneously synthesizes highly advanced beneficial polysaccharides.
Right.
And these have been shown to significantly lower cholesterol and regulate lipid metabolism.
That is wild. I mean, if a common fungus can serve as a Gothic bug mansion, synthesize advanced cardiovascular medicine, and root up space shuttle propellant all at the same time.
It really makes you wonder.
Yeah. What other radical, undiscovered chemical technologies are quietly growing right under our feet? It's definitely something to mull over the next time you take a walk in the woods.